Okay, this is a 2018 AP Calculus AB practice exam. This was not the exam that was given in 2018, but the official practice exam. And we're in this video, I'm going to cover parts of number 1 and parts of number 2. Those parts that I don't expect to be on the 2020 test, I will not work and tell you why. So number 1, you have a table, and it's about grain being added to a silo. And that grain is added to a silo in cubic feet per minute. And that's G of T, and then here's the time in the top of the table. So part A says, using the data in the table, approximate G prime of 3, and then interpret the meaning G prime of 3 in the context of the problem. That interpreting part is important. Okay, so what you want to do to get G prime is to get the slope of something that surrounds 3. Okay, so you want to get the slope between 1 and 5. You don't want to do the whole thing from 0 to 8. That won't give you as good an estimation as if you close down in and do the 2 endpoints on either side of 3. Okay, so G prime of 3 is going to be approximately equal to G of 5 minus G of 1, okay, the change in y over the change in x, 5 minus 1. So that's 20.5 minus 15.1 over 5 minus 1. So this one, you'll be able to use a calculator on the test. They would probably give you easier numbers than this on the 2020 test, but when you put that in your calculator, you get 1.35. Now, if you want to know the units, it's the units for G of T, which is cubic feet per minute, divided by the units for time, which is minute. All right, so that's going to be cubic feet per minute which, if you took physics, you know that you could just be put per minute squared. Okay, so another very important part though is, what does that mean? Okay, and so the explanation would be, at t is equal to 3 minutes, the rate at which grain is added to the silo what does a derivative mean? Is, since it's positive, it is increasing at a rate of 1.35 cubic feet per square minute. So that's really an acceleration, isn't it? So the acceleration of the volume. Okay, so for that one, it'd probably be worth 2 points. The answer would be worth a point, and the explanation's worth a point. So spend time on the explanation. Okay, part B, I think I can fit at the bottom of the whiteboard here. It says, write an integral expression that represents the total amount of grain added to the silo between time t equals 0 and t equals 8, and use a Wright-Riemann sum with 4 subintervals indicated by the data in the table. Okay, so a Wright-Riemann sum. So we're going to be using the right sides of each one in this table. Okay, I definitely think this is fair game on the test. I could see them giving you something like this. So the expression is just going to be 0 to 8 of G of T dt. That would tell you the total amount of grain. but it's going to be approximately equal to, so we're going to do the right Riemann sum. So our first base is from 0 to 1, so that's a length of 1, and our first height is the right side of these two. Okay, if it were the left side, you'd pick, if it were left Riemann sum, you'd pick 12.8. If it was a midpoint Riemann sum, you'd average those two numbers. This is a right Riemann sum, so 15.1. What's the second base? Well, it's between 1 and 5, so that distance is 4, and then the right height is 20.5. The third is between 5 and 6, so that's a base of 1, and the right value between 5 and 6 is 18.3. And then finally, the last base between 6 and 8 is 2, and the right value is 22.7. Probably get easier numbers than that on the 2020 test, but if you put that in your calculator, that'll give you 160.8. All right, and that, of course, you've got to get the unit right, and that's going to be cubic feet. Okay, definitely fair game. So I think A and B are both possibilities for the 2020 test. Now C, part C, I do not think is going to be on the test, but I do want to go over it just a second because it relates to part D, and I think something on part D could be on the test. So let's see if I can fit part C down in here. So part C says the grain in the silo is spoiling at a rate of WT, and it gives you that pretty nasty function there, where WT is measured in cubic feet per minute. Using the result from part B, approximate the amount of unspoiled grain remaining in the silo at time t equal 8. Okay, so what you're going to have, the amount remaining is going to be that 160.8, which is the amount that was added from part B, and then the amount that spoils. Okay, you would integrate from 0 to 8 of WT dt. And of course, this would be a calculator problem on the real test. So that answer is 90 something. So the amount ends up being 61.749 cubic feet. All right, so I just wanted to go over that a second because it kind of relates to part D, which I do want to go ahead and work. But this part right here, where you're having to accumulate something with an integral, is not on the 2020 test. All right, but they might give you that number though. So you didn't have to do this. They might give you the number, and then you would have to use logic to see the amount remaining. All right, if you need to pause the video, go ahead. I'm going to erase all of this. All right, let's take a look at part D. So part D says, based on the model in part C, is the amount of unspoiled grain in the silo increasing or decreasing at time t equals 6? Well, all you need to do is the amount of grain added at time t equals 6 is g of 6, which we know is 18.3. And then the amount of grain that spoils at time t equals 6 would be w of 6. So is this positive or negative? If it's positive, then the amount of grain in the silo is increasing. If it's negative, then it's decreasing. So g of 6 we know is 18.3. W of 6, you would plug in to the function, the 32 times the square root of sine of pi t over 74. You just plug 6 in for t. Okay, and if you do that, and they would give you something on the 2020 test that you could do in your head, but it's 16.06. So that is greater than 0, so it is increasing. The amount of grain added is greater than the amount of grain that spoils, so it's increasing. So they might give you one like that on 2020 with an easier number, an easier function that you could just, maybe be x squared plus 7 or something, right? Instead of this square root of sine function. All right, that's number 1. I'm going to go ahead and erase this and go ahead and find number 2, and we'll do parts of number 2 on this video. All right, number 2 says a snail is traveling along a straight path. The velocity of the snail can be modeled by v of t is equal to 1.4 times the natural log of 1 plus t squared. And that is in inches per minute, and it's between 0 and, in fact, it's greater than or equal to, so 0 and 15. Okay, so that's our time, between 0 and 15 minutes. So first, we want to find the acceleration. Okay, so that's just going to be v prime of t. All right, that's totally fair game on the 2020 test. If you have a velocity problem that involves taking a derivative, then it's fair game. So if they gave you the position function and you needed to get velocity, you take the derivative of position. This time they want to know acceleration, so you take the derivative of velocity. Okay, so the derivative would be 1.4. How do you take the derivative of natural log? Well, that's 1 over the blob, so 1 over 1 plus t squared times the derivative of the blob, which is 2t. So v prime at 5, just plug a 5 in for t, and that is 0.538. All right, and so this is inches per minute, so acceleration would be inches per minute, which would be inches per minute squared. All right, I think one like that would be fair game. Okay, part B says, what is the displacement? Okay, probably not on the 2020 test, because in this case, we know that to get displacement, all right, we would have to integrate v of t from 0 to 15. Okay, and you're not going to be integrating a velocity problem. At least that's what they're saying, that you are not going to be doing that. So if they hold true to their word, then that won't be on there. Now part C says, at what time between 0 and 15 is the snail's instantaneous velocity equal to its average velocity? Okay, so this one I think is a possibility. You will need to know how to get an average using integration. Okay, so the average velocity is going to be, you're going to have to do 1 over b minus a from a to b of v of t dt. Now, on the 2020 test, it would probably be an easier function to integrate than that. Okay, so that's going to be 1 over 15, and then you would integrate from 0 to 15 of 1.4 natural log of 1 plus t squared. Okay, this one is difficult enough we'd have to use a calculator, but they would give you one that's easier to integrate, one that you can do by hand, but this would be 5.06 So when does the instantaneous velocity equal the average velocity? Okay, so what you would do then is set v of t, 1.4 natural log of 1 plus t squared, set that equal to 5.069, and then solve. Again, on the 2020 test, they would give you one you could solve by hand. Okay, but if this particular one, you would have to use your calculator, use the solve function, and what you would get is 6.031 minutes. Worth going over, even though it's harder than what you would be doing on the 2020 test. The process is the same. Now, part D involves integration. Okay, so even though this involved integration, you will have to integrate if it's asking for an average. Okay, you'll have to know how to do that. But part D involves integrating acceleration to get velocity. So part D is not going to be on the 2020 test. Okay, that does it for this video. We will pick up with number 3, if that one is valid for 2020, on the next video.